All right, I'm sorry for the extra video for homework, but here we go. We're going to take a look at these 8 issues and see if we have, or what type of relationship we have, and we're going to write an equation. We're not going to do this part. We're not going to solve the problem. So a cylinder has a height of 16 inches. The cylinder relationship between the volume, V, and the radius of the cylinder. So we know that the volume of a cylinder is equal to pi r squared times the height, because we have the area of the base times the height. Well, we don't know the volume, but we know the height. And the height in this case is 16 inches. Well, we know 16 times pi, well, that's just going to be a number. It's going to be close to 50. And we have r squared. Well, we know that if we have a variable squared, we are talking about a quadratic relationship. Now for number 2. All right. For number 2, a rectangle has an area of 24 square inches. Consider the relationship between the width and the length of the rectangle. Well, I know the area of a rectangle is equal to the width times the length. Well, it tells me the area is 24 square inches. Sorry for transposing those. And we know that an inverse variation has the 2 variables multiplied together, and it will always equal a constant, in this case, 24. So we have an inverse variation. For problem number 3, we have a laptop that costs $800, and it loses 50% of its value each year. That's depressing. Consider the relationship between the value of the laptop and time. Well, given that stat, I think I'm going to buy last year's model every time. Well, we know that when we're dealing with a loss of a percentage, we're talking about an exponential decay situation. And exponential decay can be written in its equation form as y equals a times b to the x power. And exponential relationships simply mean that the exponent is the variable. And so we have a y-intercept of our initial value, 800. So y is equal to 800 times 50% as a decimal to the x power. And this is called the decay factor. All right. For number 4, 4 is probably the trickiest one in the bunch because they're trying to trick us. The first customer buys 2 magazines. Then it says the second customer, he had 4 total magazines. So the second customer, he had 4 total magazines. For the 8th customer, notice how he's skipped an awful lot. We have 16. Well, just looking at the numbers, I'm really tempted to say it's exponential growth. We're doubling every time, but it's not because we went from 1 customer to 2 customers to 8 customers. And I noticed that 1 times 2 is 2. 2 times 2 is 4. 8 times 2 is 16. This is linear with a slope of 2 and the y-intercept, well, going backwards, we get 0. So just plus a 0. This is a proportional relationship. All right, for number 5, a cylinder, a cylinder again, has a radius of 4 inches, and we want the relationship between the volume and the height of the cylinder. Well, you'd be tempted to say this is quadratic because we said the first one was quadratic, but let's take a look. So we know that volume is equal to pi r squared times the height. Volume is equal to pi, well, we know the radius is 4 squared times the height. 4 squared is 16. So we have volume is equal to 16 pi times the height. Well, 16 times pi, again, is a constant. It's a number. It's going to be around 50. And now we have a variable to the first power. Well, when we have our variable to the first power, this is linear with a slope of 16 pi and a y-intercept of 0. All right, number 8. Jorge keeps track of the number of people who visit his new website every day. On the first day, he had 3 visitors. So first day, 3 visitors. After the number 4, I'm going to make a table because I don't want to get tricked again. On the second day, he has 9 visitors. On the third day, he has 27. And the fourth day, he has 81. I can't help but notice I'm multiplying by 3 every time. That's exponential. So going backwards, divide 3 by 3, I get 1. So we have y is equal to my y-intercept of 1 times my growth factor, 3 to the x power. Number 7. Oh, I'm sorry, this is exponential growth. Number 7. Unit squares are arranged as shown below. Figure 1 has 1 rectangle. Figure 2 has 3. Where did the 3 come from? Oh, well, I have, sorry, that's 1, 2 rectangles, and I also have a big sneeze. The 2 combined, that's another third rectangle. So I have 1 and 1, 2 and 3, 3 and 6. This isn't linear, and it sure as heck isn't exponential, because 1 times 3 is 3, 3 times 3 is not 6. So I have the 1, first figure, second figure, and the rectangles. Figure 3 has 6, 3, 1. Oh, well, that's a difference of 2. It's a difference of, the next one's going to have a difference of 4. Oh, this really reminds me, this is a triangular number pattern, isn't it? And I'll remember that a triangular number pattern is quadratic. This is just like the high fives that we had, or the handshakes. This is actually more like the handshakes, less the high fives. And the equation for that was n times n minus 1 divided by 2. In this case, that would be r. Let's call this n. All right. Finally, a basketball manufacturer needs to know the relationship between the volume of the ball and its radius. Consider the relationship between the volume of the sphere and the radius. So we know the volume of a sphere is 4/3 pi r cubed. Cubed. And, well, so quadratic has squared, linear has to the first power, exponential has an exponent that is a variable, inverse has x times y, or a value k divided by a constant, or divided by your x value, your independent variable. I don't know anything that has an r to the third, or anything to the third power. This is called a cubic relationship, or none of the above. And the fun thing is it has a graph that looks like this. I can do a better job of that. There you go. Super fun. Anyways, cubic functions can be even more fun. More advanced ones look like that. Cool n-like feature. All right, well, that's the end of the video. I hope you did well on this investigation, and I can't wait to see you tomorrow. Good night.